Next, we'll be considering remainder theorem and factor theorem. So two theorems, not just remainder theorem, okay? Remainder and factor theorem. Okay, so the remainder theorem states that if you have a polynomial, which we call px in x, then the remainder when px is divided by x minus b is pb. That is, if x minus b divides px, it means that your remainder will be pb. I will explain that to you, okay? Meaning that wherever you see x, you plug in b in the polynomial. You'll see an example. We'll consider an example shortly. Now, for the factor theorem, it says that if this same polynomial vanishes whenever x is equal to a, then x minus a is a factor of px. That is, if pa is equal to 0, that's what it means by vanishing. It means that x minus a divides px. That's what it means, okay? Sorry, you're in 100 level. When you get to 2, you understand what this line means. It simply means divides, okay? Okay, so let's consider some examples so that you'll see us apply both the factor theorem and the remainder theorem. So yeah, factor and remainder theorem. So it says find the remainder. The first example says find the remainder when x to the power 3 plus 5x to the power 2 minus 2x minus 1 is divided by x plus 3. Now, what does the factor theorem say? I'm sorry, the remainder theorem, because that's what we're looking for. We're looking for the remainder. It says that if you have a polynomial in x, that the remainder when the polynomial is divided by a certain value, this value x minus b is pb. So we just need to compare what divides. This is what divides x plus 3, and what divides in the theorem is x minus b. So comparing this, we have x, right? Let me clean it so that to be clearer. So we compare. So our polynomial px is this, right? That's our polynomial. So we compare this to now. X remains x, and clearly minus b must be the same as positive 3, right? Means that minus b is going to be same as 3. This means that my b is 3. Okay, so we found b, because we need to find, remember that theorem says we should find pb. So wherever you see b, you're plugging in 3, right? So now we're looking for p3 because we found the b for this particular question. Okay, so but we know what px is. Px is this polynomial here, right? That's why you're seeing it written this way. But now we're looking for wherever, so I have compared the two, remain the divisors, what divides this and this, which is why I'm having this equality, and the b is minus 3. Well, b is actually, oh sorry, I forgot, b can be 3 but minus 3 because there's a minus here, right? So that's true, it's minus 3. So the b is minus 3. So we found the b. So we plug it in now. So we're looking for PB, and our B is minus 3, not P3 because of the minus sign which I left out. So let's be careful with that minus sign. Be very, very careful, especially for your multiple choice questions. Okay, so we need to find PB. Now we know what PX is. It is this. Meaning that wherever I see X, I'm just putting back B, right? That's why you're seeing B, B, B everywhere here. But we know what B is. We got B to be minus 3. So wherever we see B now, we're putting back minus 3. So that's why you see P minus 3 is equal to what you see on the screen here. Wherever there's a B, and note I put a bracket because this minus 3, the minus sign can be very confusing and tricky. So you put a bracket for wherever the minus 3 is. So wherever B is, and put the minus 3 in the brackets. That's what I've done all through, as you can see on the screen. So if you simplify, after simplifying, your final answer has to be 23. So we found the remainder. The remainder is 23. Okay, thank you. So that's that question. The next exercise says find the value of m. If x minus 2 is a factor of this, so x minus 2 is a factor, meaning that x, so this is now our polynomial px, right? Sorry. Let me start all over. So this is our polynomial. This is our px. And now we're told to find the value of m, and we already know something is a factor. So we're going to be using factor theorem. That's what it means. So that's why I've written the factor, I copied and pasted the factor theorem here so that you can remember what it says. It says that whenever something is a factor, it means that something is vanishing at the point x equal to a. In our case here, this is a factor, and this is our polynomial. And we're told to find m. But we know what, if we can just get this thing to go to 0, we can solve something, right? So that's what we're going to start with. Okay, so the theorem allows us to link all we're doing together and find a possible solution. So this is our factor. This is x, and both of them are the same. There's a minus sign. There's a minus sign here. There's a minus sign here. So a will just be 2. Okay, so we found a. A is 2. And it says what vanishes? It says PA is the one that vanishes. It goes to 0. So that's what I've done here. And following that, PA will be equal to this. Wherever we see A, we plug it in this equation, right? Because it's our PX, right? It's our PX. So wherever we see x, now we put the a's. So that's why you see this equation on the screen. But we know what a is. It's 2 when we compare the factors, right? Okay, so with that, we solve for P2. So wherever you see A now, we're putting 2, 2, 2. I didn't need the bracket. Oh, I still use the bracket. Let's just continue to use the bracket. It's safer for all of us. So we put the 2, 2 wherever you see A, and then you get this value. And everything is in with M, because that's what we're looking for. We don't know what M is. And then you simplify, and you finally get M to be minus 4. I said you should refer to the lecture notes for more information, more examples, and many more in the lecture notes itself. Okay, so with that, these are the exercises I expect you to solve. So this is to be solved and submitted to during the live class.